Okay, good day, everyone. So today, we will be discussing about modular arithmetic. By the way, I am Teacher Rose. So let's get started. Okay, our class objectives for today is to define modular arithmetic, modulus, integer, and congruence. Second is to perform clock arithmetic and day of the week arithmetic. Third is to determine whether a congruence is true, solve congruence equations, perform arithmetic operations using modular arithmetic rules, and lastly, find the additive and multiplicative inverses in modular arithmetic. Okay, are you excited? So far, excited man? Okay, amo gid na, dapat lang. Very good. Okay, so the materials I used for this presentation is PowerPoint presentation and Canva. Our motivation, well, wala po tayong motivation for today's video. Kung gusto mong mag-give up, hindi lang tani. Layo ka pa, pero layo ka na. Padayon. Okay. Ari ang atong table of contents, the definition of modular arithmetic na itakol ta na, introduction to modular arithmetic, congruence, arithmetic operations, additive and multiplicative inverses. So amo ni sila ang aton nga mga ipang-discuss sa sini nga topic. Proceed ta. We have here the definition of terms. So, amo ni nga mga words ang inyo pirning ma-encounter no, as we go along our discussion. First word is the modulo. It is a mathematical operation that finds the remainder when one integer is divided by another. In writing, it is frequently abbreviated as mod or represented by this symbol. For two integers a and b, a mod b is equals to r, where a there is the dividend, b is the divisor or the modulus, and r is the remainder. Second word, we have here modulus congruence. It means that both numbers, for example, 11 and 16, have the same remainder after the same modular. Amo na siya ang definition sa modulus congruence. Sige lang class kay mabalaan nyo lang gitna as we go on, ha? Okay, third is integer. So, I believe familiar na ko kana kamo sina nga word sa integer, no? Kay ara na pag elementary, correct? Okay. So integer, it is a number with no decimal or fractional part from the set of negative and positive integers including 0. And lastly, are familiar man ni, I believe. Okay, ang remainder. So it is the value left after the division. Proceed. So, ari na kita, the definition of modular arithmetic. So, mga langga, ari siya si Carl Friedrich Gauss, siya ni ang nag-introduce sa modern approach to modular arithmetic. Nan, ari ang iya book. Hindi ko kabasa, hindi ko kabalo kung ano na pagbasa, but amo na siya. Ang book ni Carl Friedrich Gauss, which was released in 1801. Nan. Okay, let's proceed. So in mathematics, modular arithmetic is a special category of arithmetic that makes use of only integers. Timanda A, they arithmetic or modular arithmetic only makes use of integers. Okay? Okay. So in other words, it is the arithmetic of congruence. So modular arithmetic is sometimes known as clock arithmetic nga ma'am, as one of the most familiar uses of arithmetic is in the 12-hour clock, which has the time period divided into two equal halves. Nan. Nga ma'am nga, it is also known as clock arithmetic. Okay, ari. So many clocks have the familiar 12-hour design, right? Okay. So we design, ari example clock, nan, ara siya sa left, ara sa ang figure sa left, that is a clock. So it has a 12-hour design. So we designate whether the time is before noon or afternoon. Before noon gani, that is morning. Afternoon na siya, hapon, and then evening. Yan. So we use these abbreviations AM and PM. Familiar ka mo sina? AM and PM? Yes. So a reference to 7 a.m. means 7 hours after midnight. So after midnight, that is already AM. That is morning na, no? 7 a.m., 8 a.m. nan. And then a reference to 7 p.m. PM naman, it means 7 hours after 12 noon. Nan. 7 p.m., 6 p.m., 5 p.m. In both cases, once 12 is reached on the clock, we begin again with 1. Kita niyo na, class O, ang figure O. After siya 12, nagbalik siya sa 1. Wala siya nag-13, 14, 15, wala siya nagpadayon. Kundi, nagbalik siya liwat sa 1. Nan. So, dari na ta. Nakulbaan si ma'am. Hari. So in both cases, we begin again with 1. So if we want to determine a time in the future or in the past, it is necessary to consider whether we have passed 12. Correct. Kay kung, for example, if the clock is already past 12, that is already noon or PM. Very good. But kung wala pa nakapas sa 12 or wala pa nakalabot sa 12 ang clock, that is yes, very good. It is AM and or morning gali. Sorry. Yes. Are. So to determine the time 8 hours after 3 o'clock na, we add 3 and 8. Na, i-add ta ang 3 and 8. And because we did not pass 12 o'clock, the time is 11 o'clock. Ari guys, lantawan ninyo ang clock. For example, ibutang taabi, aran na siya, na siya no? 3 o'clock. So, ang ubrahon ta, add lang ta 8. 3 o'clock, add ta 8. So, 3, 4, pag 4 na, sugot ta 1. Na 1, 2, 3, 4, 5, 6, 7, 8. O 8, ang nakatuon siya sa 11. So that means 3 o'clock or 8 hours after 3 o'clock is 11 o'clock. Yan. However, ay naman, to determine the time 8 hours after 9 o'clock, we must take into consideration that once we have passed 12 o'clock, we begin again with 1. Ari naman, for example, the time is 9 o'clock. Butang ta 9 o'clock. So what we will do is to add 8 no sa 9. So 9 1 sa 10 ta pag kwanta sa arrow sa 10, that is 1 na, ha? 1 na ang pag-count. So 1, 2, pila ganito, 8 hours no. So 1, 2, 3, 4, 5, 6, 7, 8. Nan. So, nagtuon siya sa 5. So, meaning, 8 hours after 9 o'clock is 5 o'clock. Timandaan ta class nga pag nakapas na ta sa 12 gani, mabalik na siya sa 1. Hindi na siya 13, 14, no, ha? Okay, very good. Let's proceed. So, are, we will use the symbol. Okay, are ang symbol class O. Circle, tapos inside the circle, we have there the plus sign. We use that to denote addition on a 12-hour clock. Ginagamit na siya sa clock arithmetic, ang ini nga symbol. Okay, class, gets? Okay. So, using the symbol, are, 3 plus 8, amo ni siya ang solve ta. So, 3 plus 8 is equals to 11. And then 9 plus 8 is equals to 5 on a 12-hour clock. Nan. So, amo to ginobra ta no, class, no? Gin-add ta ni sila, no, ang 3 o'clock, 8 hours after 3 o'clock. So, gin-add ta ang 3, ag 8, kag natuon ang clock sa 11. And then, 9 plus 8, nag-add ta 8 sa 9, and then, nagtuon ng clock sa 5. Aside sa addition, we can also perform subtraction on a 12-hour clock. So if the time now is 10 o'clock, then 7 hours ago, the time was 3 o'clock. Kung kagina pa forward aton paglakat sa clock, no, pa forward, diri naman pa backward. Nan kay hours ago, meaning before. Nan. So which is the difference, arina? So 10 and 7, i-minus na sila, we will get 3. So, it was 3 o'clock 7 hours ago. Nan. However, if the time now is 3 o'clock, then we see that 7 hours ago, it was 8 o'clock. Ari nga symbol naton gamiton class, no? To denote subtraction. Ari, circle, and then susulod sina, we have the minus sign. Yan. Ang kagina, plus sign to inside sa circle, that denotes addition. Ari naman, nga sign ang minus sign nga ara sa sulod sa circle, it denotes subtraction. Yan. So we can write 10 minus 7 is equals to 3. And then 3 minus 7 is equals to 8. Ari class. So let us perform. Sino gusto mag-answer sa wala na question, no? Dere, wala na question? Okay, very good. Ari, may ansiran ta. Ari, perform clock arithmetic. Evaluate each of the following, where plus and minus, or these symbols, indicate addition and subtraction respectively on a 12-hour clock. So, pwede ta ka base sa clock. Pwede ta ka gamit kung may mga orasan ka mo dira, pwede nga siya gamit as inyong basihan in answering these following equations, no? So letter A, letter B, letter C, and letter D. So who can answer letter A? Okay, yes. Yes, okay. Letter B, and then letter C, and then letter D. Very good, okay. Let's check your answers. Thank you so much for answering. Let's check your answers. Okay, adding solution. Calculate using a 12-hour clock. Okay. So, ano inyo ginhimo? Letter C, ari ng mga answers. Ben, tsakto, mga answers. Okay, very good. In tsakto. So, aring solution, 8 plus 7, obrata? We just added 8 plus 7. For example, amo siya ang situation class ha, 8 o'clock karon. So what is the time 8 o'clock or after or 7 hours after 8 o'clock? So it is 3 o'clock. Very good. Ari class. Ang situation naman diri sa letter B, imagine it is 7 o'clock karon. So what is 12 hours after 7 o'clock? It is 7 o'clock. Okay, very good. Correct. Okay, letter C. Diri naman. Kay subtraction diri nga sign, meaning natabo na, meaning before. So ari, kung 8 o'clock karon, what was the time 11 hours ago? From 8 o'clock. Okay, so nag-go backward lang kita. We have 9. It was 9 o'clock 11 hours ago. Very good, correct. Okay, letter D. Diri naman. 2. So it is 2 o'clock karon. So what was the time 8 hours ago? Okay, so okay, very good. 6 o'clock. Okay, very good. Very good, kinakaintindi. Okay, let's proceed. Okay, another note here is a similar example involves day of the week arithmetic. Agina class we discussed no about clock arithmetic. And now we will also discuss day of the week arithmetic. If we associate each day of the week with a number as shown, wala ko nabutang class, I'm so sorry. Basta Monday, gi-indicate siya, it is associated with the number 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, Saturday 6, and then Sunday is 7. Okay? Okay, very good. So, ari na. Then, 6 days after Friday is Thursday, and 16 days after Monday is Wednesday. Symbolically, we write, ari na, class, basig, ma-confuse ka mo, no? Tani, I'm sure hindi mo guro ka mo ma-confuse. Ang ani nga symbol, ang square, no? Ang square, tapos may plus sign sa sulod. Gadinot po na siya, addition, pero hindi na siya naton ma-apply sa clock arithmetic. Kay ang ini nga symbol iya ni siya sa day of the week arithmetic. Okay, gets class? Okay, very good. Okay, proceed ta. So we write 5 plus 6. Ang 5 diri, it is associated with Friday. Very good. And then 16 days ano ni Friday, then 6 days na. Ang 6 diri 6 days after Friday. Oh, ano na siya? Ano nga day ang 6 days after Friday? We have here equals 4. 4, ano ang associated nga day sa 4? Very good. Thursday. Thursday. So, meaning, kung Friday karon, 6 days after Friday is Thursday. Pwede mo lang na ma-count class, no? Kung, pwede na siya ma-count. For example, it is Friday karon. So, count ta. Friday, Saturday, count lang ta 6, no? Friday, Saturday, Sunday, Sunday, Monday, Tuesday, Wednesday, Thursday. Nan. So, ang ika-6th nga day, that is Thursday. That's why 4 aton answer diri. Yes, okay. Gets? Okay. The same man diri sa 1 and 16. So, 1 year, it is equivalent to Monday. And then, 16 days after Monday is, Wednesday. Nan. That is why 3 ni diri. May ara pa gid another technique sina class. Instead nga mag-count-count ka, may ara pa gid another technique sina. Ang aton obrahon, sige, basahan ta ni ana isa ka note ha. So we are using this symbol for days of the week arithmetic to differentiate from this symbol na. Ari nga symbol para ni siya sa clock arithmetic. Manda class basta gapa circle gani iya na sa clock. Tawa ang clock gapa circle, o di ba? Or di mo gulo tanan nga clock gapa circle pero mostly noon, no? Yes. So another way to determine the day of the week is to note another naman ni nga technique class instead nga magsigita instead nga sigita count, no? So when the sum of 5 and 6 is 11 and then divide it by 7. The number of days in a week. The remainder is 4 class. So another technique para easy ni siya nga technique para makuha ta dayon ano nga day, no, ang gipangita. So kunon ta butang ta aton mga given. We have here 5 Friday, since on Friday ika-5th nga day, so ara na siya 5. And then add lang ta 6 days, no, kaya mo na ang ginapangita 6 days after, so plus 6. So 5 plus 6 we have 11, okay? Muna siya ilasam. And then, ang ilasam, i-divide ta ni sa 7. Nga 7, ma'am, because there are 7 days in a week. Gets? Okay. So, 11 divided by 7, okay? And then, the remainder is 4. So, ang 4 dara, mga langga, ang remainder ta, amo na siya ang aton nga answer. Okay? So, 5 plus 6 was 11, and then 11 divided by 7, and then our remainder there is 4. So, ang answer natin kay 4, which is, ano gani ang equivalent sa number 4? Thursday. Very good. Amo man na siya, the same with this equation, no? 1 plus 16, add lang ta, is equals to 17, and then 17, i-divide ta siya sa 7. So 7. And then the remainder there, that will be the correct answer, or that will be the day nga ginapangita. So ang answer dira is 3. So ang 3 is equivalent to Wednesday. So the answer is Wednesday. Okay? Nan. Nga okay, basahan ko na lang. This works because the days of the week repeat every 7 days. Nan. That is why ginadivide siya sa 7. Nan. So the same method can be applied o ari man class. Instead nga magsige man ta count no kagina sa 12-hour clock no sa aton clock arithmetic, pwede ta man uh, add. Ari for example, if it is 8 o'clock karon, what will be the time 7 hours after 8 o'clock. So i-add ta lang 8 plus 7 equals 15, and then class we divide it by 12 nga kay ang sa clock 12 hours lang. Very good, 12 hours. So i-divide na lang siya sa 12, and then kung pila ang remainder ta, that is the answer. So 8 plus 7 is equals to 15, and then we divide it by 12, and then our remainder there is 3. So our answer is 3 o'clock. That is the time 7 hours after 8 o'clock. Okay? Okay, very good. So, are, another slide. Situations such as that repeat in cycles are represented mathematically by using modular arithmetic or the arithmetic modulo n. In modulo n, two integers a and b are said to be congruent modulo n, where n is a natural number if a minus b over n is an integer. So in this case, we write a is congruent to b. Ari nga class, aning tatlo ka line, ga-symbolize na siya congruence. Okay? So a is congruent to b, mod n. Mod or modulo. Okay? Okay. So the number n is called the modulus. Modulus. Amo na nga. Mod n. So the statement A is congruent to B, mod n is called a congruence. So we have to take note. Also, there is a history note here. The congruent symbol consisting of the 3 bars at a class o ring ang symbol sa congruence, it was introduced in print in 1801 man gyapon by Carl Friedrich Gauss. Siya man gyapon ang nag-introduce na. Okay, ari class. May ara ta diri example. Ansiran taning letter A, and then pagkatapos answer sa letter A, kamo answer sa letter B. Okay? O sige. So are, ang letter A, let us determine whether the congruence is true. So 29 is congruent to 8 mod 3. What will be the answer? How? Are, ay, nabutang ko na galing solution class. Pero are ang solusyon. So 29 minus 8 over 3. Are 29 minus 8 is 21 over 3, and then pwede pa na siya ma-round off 7. Correct? Okay. I mean, i-divide tagali. I'm so sorry. So, divide the 21 divided by 3, we have 7. That is why 7 over 3. Because 7 is an integer, meaning 29 is congruent to 8 mod B. It is a true congruence. Nga gani kay integer. Basta integer gani ang answer class, true congruence na siya. Okay? The same man diri sa letter B. 15 congruent to 4 mod 6. How to answer this, class? Okay, find 15 over 4 over 15 minus 4 over 6, and then 15 minus 4, we have 11 6. So because 11 6, ay class, wala ni gali diri 3 ang below sa 7 ha. Wala ni diri kay basi ma-confuse ka mo la 7, because 7 is an integer. Ang answer man diri 7 over 3. Sala na class, sala si ma'am, I'm so sorry. 7 lang na siya gali ha, 7 na siya, I'm so sorry. Okay, ari So let's go back now sa letter B, find. Okay, so we have here 11/6. Oh, since 11/6 is not an integer, yan, meaning 15 congruent to 4 mod 6 is not a congruent. Very good. Okay, another note. So 429 is congruent to 8 mod 3 given in example 2. Example 2. Note that 29 divided by 3, the modulus, is equals to 9, remainder 2, and that 11 divided by 3, the modulus is equals to 3, remainder 2. Both 29 and 8 have the same remainder when divided by the modulus. So this leads to an important alternate method to determine a congruence or a true congruence. If A is congruent to B mod n and A and B are whole numbers, then A and B have the same remainder when divided by m. Are, let us answer this alternate method, no? In an alternate method. Are naman, kung kagina, ginapamangkot ginhatag ta lang ang ari o ang equation, tapos solve ta lang kung congruent, kung ginsolve ta lang, tapos makaano na ta dayon kung true congruence ba na siya. Ari naman, alternate naman. Is 33 congruent to 49 mod 4 a true congruence? That is answer. That's answer. Ready na? Okay, very good. Okay, aring answer ta. Yes. Is this equation, or is 33 congruent to 49 mod 4 a true congruence? Yes. Why? Because 33 divided by 4, ari class A, nan. Divided by 4 is equals to 8, and the remainder is 1. And then 49 i-divide naman sa 4 is 12. Remainder taman kay 1. So both 33 and 49 have the same remainder, which is 1 when we divide it sa 4. So meaning it is a true congruence. Entiende? Okay, very good. So far, so good. Okay, another note. So, example naman siya. Now, suppose today is Friday, days naman. To determine the day of the week 16 days from now, o today is Friday, so what will be the day 16 days from now? So we observe that 14 days from now, the day will be Friday. So 16 days from now, the day will be Sunday. Okay, so note that the remainder when 16 is divided by 7. Nga gani 7 diri? Okay, very good. 7 is 2. Using modular notation, 16 is congruent to 2 mod 7. So the 2 there signifies 2 days after Friday, which is, very good, Sunday. Okay, are. Ay, may solution na gali si Ma'am Dre. Okay, so July 4, 2017 was a Tuesday. So what day of the week is July 4, 2022? Man, okay. So aring solution ta. So there are 5 years. Seven from 2017 has 2022. So there are 5 years between these two dates. Each year has 365 except 2020 kay may ara extra nga day kay leap year ang 2020. So the total number of days between the two dates is 5 times 365 plus 1 is 1,826. And because 1,826 divided by 7 is equals to 260, remainder 6, meaning 1,826 congruence 6 mod 7. So any multiple of 7 just past a given day will be the same day of the week. Nan. So the day of the week, 1,826 days after July 4, 2017 will be the same as the day 6 days after July 4, 2017. So July 4, 2022 will be, yes, will be a Monday. Okay. Are may leap year formula man ta. The calculation in example number 3, are goro nan. Required that we consider whether the intervening years contained a leap year. Yes, ang 2020 gina may leap year. So there is a formula based on modular arithmetic that can be used to determine which years are leap years. The calendar we use today is called the Gregorian calendar. This calendar differs from the Julian calendar in that leap years do not always occur every fourth year. So here is the rule. Let y be the year. Arin siya sa, parang siya sa leap year class ha. So let y be the year. So if y is congruent to 0 mod 4, then y is a leap year unless y is congruent to 0 mod 100. So in that case, y is not a leap year unless y is congruent to 0 mod 400. Then y is a leap year. Using this rule, for example, 2008 is a leap year because 2008 is congruent to 0 mod 4, and 2013 is not a leap year because 2014 is not congruent. Class, adding a symbol, adding tatlo ka bars and then may slash nan is ano na siya, symbolize na siya sa not congruence. Okay? So 13 is not congruent to 0 mod 4. The year 19,000 was not a leap year because 19,000 is congruent to 0 mod 100, but 19,000 is not congruent to 0 mod 400. The year 2000 was a leap year because 2000 is congruent to 0 mod 100 and 1000 is congruent to 0 mod 400. Okay, let's move on. Okay, let's move on to arithmetic operations modulo n. O are, in example number 2 kagina, we verified 29 is congruent to 8 mod 3. So both 29 and 8 have a remainder of 2 when we divided them by 3, which is our modulus. Nan, kindivide na sila sa 3. So there are many numbers congruent to 8, modulo 3. But all of these, only one is whole number less than the modulus. So aton modulus is 3. So dapat less than siya, no? This number is the result when evaluating a modulo expression, and in this case, we use an equal sign. So because 2 is congruent to 8 mod 3 and 2 is less than the modulus, we can write 8 mod 3 is equals to 2. None. So in general, m mod n becomes the remainder when m is divided by n. None. Arithmetic modulo n, where n is our natural number. It requires to evaluate a modular expression after using standard rules of arithmetic. Thus, we perform the arithmetic operation and then divide them by the modulus. So the answer is the remainder. The result of arithmetic operation mod n is always a whole number less than n, or our natural number. So we have to take note, recall that the natural numbers are the usual counting numbers 1, 2, 3, 4, so on and so forth. And then the set of whole numbers consists of the natural numbers and 0. Okay, let's proceed ta. Dito sa addition of modular arithmetic. So let's evaluate. Ari class. Let us evaluate 23 plus 8, 38 mod 12. Kitanon lang. Okay, very good. So, amo na yaton solution. Let us just add 23 plus 38 to produce 61. This is their sum. And then to evaluate 61 mod 12, we will divide 61 by 12, which is our modulus. So the answer there is the remainder. Are class o. So 61 amo ni siya ang sum sa 23 and 38. And then we divide it by our modulus, which is 12. And then 61 divided by 12, 5 times 12, we have 60. And then minus 61, 61 minus 60, we have 1. And 1 there is the remainder, and the remainder is our answer. So 23 plus 38 mod 12 is equals to 1. Yes? Okay, very good. Are. In modular arithmetic, adding the modulus to a number does not change the equivalent value of the number. Are, for instance, 13 is congruent to 6 mod 7. 20 is congruent to 6 mod 7. 27 is congruent to 6 mod 7. 10 is congruent to 1 mod 3, 13 is congruent to 1 mod 3, 16 is congruent to 1 mod 3. To understand why the value does not change, let us consider 7 is congruent to 0 mod 7, and then 3 is, congruent to 0 mod 3. That is, in mod 7 arithmetic, 7 is equivalent to 0, and in mod 3 arithmetic, 3 is equivalent to 0. So just by adding 0 to a number does not change the value of the number in regular arithmetic. In modular arithmetic, adding the modulus or the mod to a number does not change the value of the number. This property of modular arithmetic is sometimes used in subtraction. Nan. It is possible to use negative numbers modulo n. For instance, we have here negative 2 is congruent to 5 mod 7 because negative 2 minus 5 is equals to negative 7 over 7. So, ano siya? Is equals to negative 1, and negative 1 is an integer. Nan. So suppose we want to find x, so that negative 15 is congruent to x. We will find x. Ayan na to siya papangita, class. Bayin na to siya. Forget him. Sure. Joke lang. Okay. So mod 6. Using the definition of modulo n, we need to find x. So that negative 15 minus x is minus x over 6. Ang 6 dara ang na aton nga mod or modulus kas ha. Okay, is an integer. So to do this, rewrite the expression and then try various values of x from 0 to modulus until the value of the expression is an integer. Basta hindi ta maglapaw sa aton nga modulus. Ang aton modulus there is 6. So dapat hindi ta malabot sa 7 ang aton mga ipang substitute as our trial and error. Ari class none. Ari. So negative 15 minus x atong ginapangita over 6. So ari gin-convert na negative open parenthesis 15 plus x close parenthesis over 6. So ari gin-try ta. So kung ang aton x is 0, we will get negative 15 plus 0 over 6, we will get 15 over 6. And 15 over 6, class, it is not an integer. Okay? So next, we will substitute 1 there is x. So 15, negative 15 plus 1 over 6. So we will get negative 16 over 6. And then, round again, simplify pa, negative 8 over 3. And this is not an integer. Okay? Basta fraction gani class, hindi na integer. Okay, gets. Very good. So next, let us substitute it sa 2. Try ta naman ang 2. So, negative 15 plus 2 over 6 is equals to negative 17 over 6, and it is not, again, an integer. Another trial and error, 3, substitute na naman ang 3, negative 15 plus 3 over 6 is equals to negative 18 over 6. And since pwede pa siya natin ma-simplify, is-simplify ta. And we will get negative 3. And negative 3 there, class, is an integer. So, ara na ta. May nakuha na ta nga answer. So, meaning there, negative 15 is congruent to 3. Kaya diba x at ang pangita gina. So, ang x dara kay 3 mod 6. Kag nga insakto siya kay, aside nga integer siya, it is also less than our modulus. Kaya mo na ang ara sa rule nga dapat ang gamiton ta nga pwede ta magamit as substitution kay hindi dapat magsubra sa 6. So it may be necessary to use this idea when we subtract in modular arithmetic. Okay, class? Question so far? Wala? Okay, very good. Proceed ta. Dali naman ta. Tapos na sa addition sa modular arithmetic, now we will proceed sa subtraction sa modular arithmetic. Ari, let us evaluate these two equations. So we have letter A, 33 minus 16 mod 6. Ari ang muna siya, no? And another one is 14 minus 27 mod 5. Itong solution sa letter A, we will have to subtract 33 minus 16. It is and it will give you the answer of 17. And then the result is positive. So we will divide the difference. Ilang difference class o ang 17, and then we will divide it sa aton nga modulus, which is ang 6. So 17 divided by 6, 2 times 6, 12. 17 minus 12, we will get 5, and 5 there is our answer. Na siya ang answer, ang solution sa letter A. And then letter B, we have here subtract 14 minus 27, so we will get negative 13. And because the answer is negative, we will find first the x, so that negative 13 is congruent to x atong kagina mod 5. Hari. So thus we find x, the value of we must find x so that the value of negative 13 equal minus x over 5 will be an integer. So trying the whole number values of x less than 5, the modulus, aton modulus kay ang yes, 5. So we find that x, kung ang aton x is 2, we will get an integer. Trial and error man gyapon class. So a negative 13 plus 2 over 5 is equals to negative 15, and then simplify, we get negative 3. And negative 3 is an integer, so it is our final answer. Okay? Gets? Okay, very good. Lapit na. Recalculating times. Dari naman ta sa time. Okay, so disregarding AM or PM. Hindi talang pag-ibot lang kung ano siya, kung aga ba siya, or gabi or hapon. So, example, if it is 5 o'clock now, what time was it 57 hours ago before 5 o'clock? Ari atong solution. The time can be determined by calculating 5 minus 57. And then our mod there is 12. Kay, we are basing it in a 12-hour clock design. So because 5 minus 57 is equals to negative 52, and it is a negative number, we will find a whole number x less than the modulus, which is 12. So that negative 52 are, is congruent to x mod 12. This means to find x, are, 52 is equals to x over 12 is equals to negative ano ta? Open parenthesis 52 plus x close parenthesis over 12 is an integer. Okay, evaluate na ta. Again, trial and error lang gyapon class. So, dire may arat na ta 8. So, amo ni ang na fit, no? Nga pwede ta i-substitute sa x. So, ari, negative, open parenthesis 52 plus 8. Ang x sige na substitute ta 8 over 12, and then we will get negative 60 over 12, and then we will simplify this, and then we get negative 5. And negative 5, class, is very good, an integer. So, 5 minus 57 mod 12 is equals to 8. Very good. Nga 8 kay amo niya nga aton gin substitute gina amo niya aton i-answer. Very good. So therefore, if it is 5 o'clock now, 57 hours ago, it was very good 8 o'clock. Okay. Dre, let's proceed sa multiplication. Wala na question sa subtraction? Wala? Okay, very good. Okay, sa multiplication, we will evaluate 15 times 23 mod 11. Okay. So let's find the answer. Here is the solution. First, let us find the product of 15 and 23. And then we will divide it by our modulus, which is 11. Okay, so the answer there will be, the remainder there will be our answer. Okay, so at una-una nga obrahon ta, we will multiply 15 by 23. So 15 times 23, we will get 345. And then, second obrahon ta, we will divide the product by our modulus, which is 11. So 345 divided by 11, 3 times 11, we get 33. So 34 minus 33, we get 1, bring down 5, and then 15 divided by 11, we get 1. 1 times 11, we get 11. So 15 minus 11, we get there 4. And 4 there is our remainder, and the remainder is our answer. Therefore, 15 times 23 mod 11 is equals to 4. Okay? Okay. Are, in solving congruence equation, it means finding whole number values of the variable for which the congruence is true. Are, for example, class, to solve 3x plus 5 is congruent to 3 mod 4, we will search for the whole number values of x for which is the congruence is true. Are, may mga different symbol ta diri, makita ta diri kung diin ang congruent, diin ang hindi congruent. Para class nan. Kung sa 0, hindi siya congruent. Sa 1, hindi mo siya congruent. Sa 2, congruent siya. Okay? So, meaning 2 is pwede ta siya mahimo nga solution. And then sa 5, kung sa 3, I'm so sorry. Kung sa 3, hindi siya congruent. Sa 4, hindi man. Sa 5, hindi man. Sa 6, congruent siya. So, meaning 6 can be our solution. Okay, class? Gets? Okay, very good. So, if we tried or if we continue trying values, we would find that 10 and 14 are also solutions. Kagina class, hasta lang ta sa 16. Pero kung ipadayon ta, we can also find that 10 and 14 are also solutions. Note that the solutions 6, 10, and 14 are all congruent to 2 modulo 4. In general, Once a solution is determined, additional solutions can be found by repeatedly adding the modulus to the original solution. So thus, the solutions of 3x plus 5 is congruent to 3 mod 4 are, we have 2, 6, 10, 14, 18, so on and so forth. Okay? Okay. When solving a congruence equation, it is necessary to check only the whole numbers less than the modulus. Nakadepende gyapon na siya class sa modulus. Kung, let's say, ano to aton modulus naton kay 4. Since kadepende ta sa modulus, dapat ang aton solution, ang aton answer, less than siya sa modulus. Biskan ang 6, biskan ang 6 solution siya, pero hindi siya Japon pwede kaya ang aton modulus is 4, although solution siya. Pero ga-base gyapon ta sa aton modulus. Karon ang aton modulus is 4, so meaning ang aton answer must be less than 4. So since 2 there is or can be a solution, 2 is our answer. Very good. For the congruence equation 3x plus 5 is congruent to 3 mod 4, we needed to check only 0, 1, and 2, and 3. Nan. Sila lang aton itry. Each solution is found. Additional solutions can be found by repeatedly adding the modulus to it. A congruence equation can have more than one solution among the whole numbers less than the modulus. The next example illustrates that you must check all whole numbers less than the modulus. Ari class, solve, 2x plus 1 is congruent to 3 mod 10. Take note ta, class ha, aton modulus is 10, meaning aton answer dapat hindi magnubo sa 10. Hindi sobra gali sa 10. Nalipat si ma'am, sorry. Are, so beginning with 0, and substitute each number less than 10 into the congruence equation. So sa 0, not congruent, you can substitute just sa 1, congruent, so it can be a solution. Sa 2, hindi siya congruent. 3, hindi man. 4, hindi man. 5, hindi man. Sa 6, it is a congruent. It is a solution. So check. Number 7, hindi. Number 8, hindi. Number 9, hindi. Kotoblanda sa number 9 because our answer should be less than lang sa modulus. So we have here 2 and 6. So the solutions between 0 and 1 are, 0 and 9 are 1 and 6. None. The remaining solutions are determined by repeatedly adding the modulus 10 to these solutions. And the solutions are 1, 6, 11, 16, 21, 26, so on and so forth. But then, dirita sa modulus gyapon nga base, that is why our answers will be 1 and 6. Okay, not all congruence equations have a solution. For instance, 5x plus 1, 3 mod 5 has no solution. None. Siya class, not a solution. So because no whole number value of f x less than the modulus is a solution, meaning wala ni aring equation, wala siya solution. Nan. Kay gintry ta na siya sa mga numbers nga less than sa 5 kay wala man gid mi nagwa nga solution, meaning this equation has no solution. Nan. Okay, let's proceed. So we will also be discussing additive and multiplicative inverses in modular arithmetic. Okay, so let's recall that if the sum of two numbers is 0, then the numbers are additive inverses of each other. For instance, 8 plus negative 8 is equals to 0, meaning 8 is the additive inverse of negative 8, and negative 8 is the additive inverse of 8 or positive 8. The same concept applies in modular arithmetic. For example, 3 plus 5 is congruent to 0 mod 8. Thus, in mod 8 arithmetic, 3 is the additive inverse of 5, and 5 is the additive inverse of 3. Here, we consider only those whole numbers smaller than the modulus. 5 and 3 are smaller than the modulus 8. None. So note that 3 plus 5 is equals to 8. That is the sum of a number, and its additive inverse equals the modulus. Using this fact, we can easily find the additive inverse of a number for any modulus. For instance, in mod 11 arithmetic, the additive inverse of 5 is 6 because 5 plus 6 is 11. And then the additive inverse of 6 is 5. Vice versa lang na siya. Are, let us find the additive inverse. Are, find the additive inverse of 7 in mod 16 arithmetic. Atong solution, in mod 16 arithmetic, 7 plus 9 is equals to 16. So meaning our additive inverse of 7 is 9. Basta class, nga anay ni siya kay ang aton lang ginapangita diri dapat hindi siya mag sobra sa 16. That's why 9 lang na siya dara. Okay? Okay. So the additive inverse of 7 is 6. The same man na gyapon kung aton diri ginapangita additive inverse sa 9. So kung ano ang aton additive inverse diri, amo man na siya diri nan ang aton answer. So kung additive ginapangita abing additive inverse sa 9, our answer is 7. Nan. So since 7 aton additive inverse sa 7 aton ginapangita, our answer here is 9. Nan. Wala ni siya labot pas ha. Hariong check your progress. Okay. If the product of two numbers is 1, then the numbers are multiplicative inverses of each other. For instance, 2 times 1/2 is equals to 1. So 2 is the multiplicative inverse of 1/2, and 1/2 is the multiplicative inverse of 2. The same concept applies to the modular arithmetic, although the multiplicative inverses will be always natural numbers. For example, in mod 7 arithmetic, 5 is the multiplicative inverse of 3, and 3 is the multiplicative inverse of 5 because 5 times 3 is congruent to 1 mod 7. And here, we will concern ourselves only with the natural numbers less than the modulus, less than sa aton modulus kay 7. So to find the multiplicative inverse of A mod M, we have to solve the modular equation AX is congruent to 1 mod M for X. Let us find the multiplicative inverse. In mod 7 arithmetic, we will find the multiplicative inverse of 2. Here is the solution. To find the multiplicative inverse of 2, let us solve this equation. 2x is congruent to 1 mod 7. Nan. X diri amo na siya ton nga multiplicative inverse. So by trying different natural number values of x less than the modulus, we will get our answer. So amo lang gyapon class, substitution lang gyapon. Basta ang mga whole numbers na aton ipang substitute dira hindi magsobra sa aton modulus, which is 7. Are, so 1 kintistingan ng 1, hindi siya congruent. Yes, hindi man siya solution. Ang 2, 3 is not also a solution, and then 4. So 4 is a solution, meaning in mod 7 arithmetic, the multiplicative inverse of 2 is 4. Okay, very good. Now we have come to the end of our discussion. Before we part our ways, I will give you some motivational quotes. Okay, let me read to you the first one. Mathematics may not teach us how to add, love, or minus hate, but it gives us every reason to hope that every problem has a solution. Life is a math equation. In order to gain the most, you have to know how to convert the negatives into positives. And lastly, here is the equation of happiness, the the mathematics of life. Life plus laughter times love minus hate is happiness. Okay. I hope you have learned a lot from our discussion. Once again, I am Teacher Rose. Never stop learning. Thank you and God bless. Bye.